Number 4 is sine of 2x minus cosine of x minus 2 sine of x plus 1 equals 0. This problem is already set equal to 0 for us. We have a little expanding we can do. We know that sine of 2x is the same as 2 sine cosine. And then everything else is just going to stay the same. You may be tempted to use a Pythagorean identity on this problem, but that's not going to help because remember we can only use the Pythagorean identity when we have squares. Here we don't have any squares, so the only thing we can do is factor. And you may be thinking, I don't know how to factor with 4 terms, but you do know how to factor with 4 terms because you're all factor masters. We can actually split this in half and just do greatest common factor on the 2 halves. So with 2 sine x cosine x minus cosine x, the like term is cosine. So we're going to take out cosine of x. Remember, we have 2 terms left. We have 2 sine cosine, 2 sine as our first term, and 1 as our second term when we take that cosine out. When we look at the second part here, negative 2 sine of x plus 1, we're going to go ahead and factor out a negative 1 so that our parentheses match. That'll let us switch our signs, and we have 2 sine of x minus 1 equals 0. Beautiful. Now we can write our 2 sets of parentheses, stuff on the outside. So cosine of x minus 1 times stuff on the inside, 2 sine of x minus 1, all equal to 0. And then that gives us cosine of x equals 1 and sine of x equals 1/2. You're probably thinking at this point, these values keep repeating, and that's because we only have a finite number of values on our unit circle. So cosine is 1 at 0 and pi. Or I'm sorry, just 0 and 2 pi, not pi, because cosine is negative 1 at pi. So we're going to say x equals 0 plus 2 pi k. And sine is 1/2 at pi and 5, or pi over 6 and 5 pi over 6, plus 2 pi k, 5 pi over 6, plus 2 pi k. Again, those are not pi apart. They don't make the same angle on the unit circle, so we're not going to condense that at all. So number 4 looked big and nasty, and it isn't at all.